Hello everyone. So in this video we will be discussing about a very common problem, that is AWS Lambda Cold Start, and then after we will see how we can optimize this cold start timing. Okay, so let's start quickly. So first we will be decomposing the request lifecycle. Like let us suppose you have hosted an application backend onto the Lambda. So how Lambda will going to execute your request first time. Okay, so what AWS will do first, it will download your code from a central repository. Then after it will sort of start a new container like on which your code will be going to run. Then after it is kind of bootstrap the runtime. So we will see this on the console as well. And once this bootstrap the runtime done, then after it will simply calls your lambda handler function. Okay, so let's see that onto the AWS console. So what I will do, I will create a lambda function. Let's name it cold start, and let's choose the runtime as Python version and keep all the settings default. Okay, so like basically we will see how does this cold start like behaving. So I will quickly jump over to the code section, and here I will just add a print message just for the sake of some change. Hello from Lambda, and then after save it and deploy it. Okay, so what happens is if you ran it first time, okay, so if you ran it first time, what it does is it says your duration is 1.10 millisecond, build duration is 2 millisecond, and then after it says init duration is 96.29 millisecond. Okay, so just keep in mind this init duration. For now it is sort of 100 millisecond around, but if you ran it next time, it says duration is same as before, build duration is same, max memory size and all those are same, but init duration is missing this time. So the reason being is like the cold start problem occurs only the first time whenever your lambda get instantiate, right? So like let's come back to this the request lifecycle. So what happens is behind the hood, AWS itself did this part, download your code and start new container. So this 2 points are not in our control. So it is already optimized by the AWS itself. So we can't do anything in this section. But what is bootstrap? The runtime is basically what it does is it basically call whatever we have written out of this lambda handler function. It is going to execute in this bootstrap runtime uh, cycle kind of. Okay, so let me write it. If let us suppose if I write import time, and then after I keep time dot sleep for let's say 4 seconds, and then after I deploy it. So what what will be going to happen is, so this bootstrap the runtime method is only executed only first time, like whenever there is some change in the lambda function or kind of your in the AWS your container doesn't exist. Okay, so if I run this, so it will obviously going to take more than 4 seconds. The reason being is we place the sleep for 4 seconds. So what it says, duration is still 1.42 millisecond, build duration is still same as before, but this time your init duration get increased by 4 seconds, right? So this init get executed first time only. We have changed, like made a change in the code. So AWS don't have the container for the same. So it kind of create a new container. But if I run this code again, this init duration will be 0. The reason being is the AWS already have the container. Okay, let me run. So duration and build duration is same, but we don't have init kind of thing, right? So this cold start is kind of some of this all the like the time taken by AWS itself, like for starting, I mean for downloading your code and starting a new container, plus the code takes to initialize the runtime. It is kind of all those things that we write outside the lambda handler. Okay, so although it is so that's basically the major problem. Okay, so just to optimize it, or maybe you can say like just to make it reduce, AWS suggested some of the steps. So I have kind of listed down all those steps in this PPT or in this slide. So we will going to discuss so how to reduce and optimize the Lambda cold start execute time. Okay, so the very first point is what AWS is suggested, like AWS says. So obviously we seen here the anything that we placed here out of the lambda handler function is executed only first time, right? So it is not executed second time. So what we can do is like anything that we are going to use in the different lambda instances. So your lambda runs, let us suppose you have a backend server and backend API server hosted on lambda, and kind of it is going to connect to DB every time, each time, right? So you need DB connection each time. So what you can do is you can place your DB connection kind of here only. So the very first time it is going to take time to make the DB connection, but second time it is going to use the same sort of uh, connection pool, right? So what AWS says is rather than creating local variables, create variables on the global level and then after use it, so that it can be used in the different executions. So I will give you an example as well. So I already have this code, so I will just going to paste it here. So in this what I have done is like obviously I have imported Boto 3 first. Second, I have initialized the S3 client as none. So S3 client as none. Then after we have lambda handler, like just global S3 client, and then after I am checking if S3 client is none kind of. So we are going to initialize it, but like if it is not none, we are saying that client is already initialized, right? So I will going to deploy this. So any guesses what will happen? So it is very obvious on the very first time this S3 client will be none, right? So it is going to print the like it is initializing client, right? But second time if we run it again, AWS have that container already is filled up, so it is not going to uh, create another new S3 client. The reason being is S3 client is already initialized, this code is already executed, right? So it will be printing client is already initialized. So let's see that. So I have like so very first time it says it is initializing client, right? If I ran it again, so it says this time client is already initialized, right? So always try to use those things that are common in different executions, right? So it is DB connections, it is anything you are importing, right? Any library you are importing. So that is the thing. So that is that we can do first. So we are kind of reusing all the variables, and obviously we are lazy, we are kind of doing lazy loading, right? Okay, so second is concise function logic. Okay, so make sure if your application have let's say you have a bigger application, right? So you are not going to put all the code combined in a single lambda. Always try to make lambda for a single purpose, right? And try to optimize like uh, uh, try to optimize as much as possible. So from the code perspective, let's say let us suppose what AWS is suggested, like kind of never use AWS function to transform, sorry I mean kind of never use to transport the data. So you are just taking reading data from A and then after putting it to the B location. So never did do that. If you are making any transform in that data, you can definitely use that. So kind of it is AWS is suggested if you are a very heavy write operation or a very heavy read operation, AWS Lambda is not the best, I think, service for that. Maybe you can like go on to the any other service. But what it says thing is if you are doing this transport as well, so always try to read as much as you required, right? So it is similar to the like if you are like you are familiar with the select star from a DB table. So rather than select star, what you can do is select column A, column B, column C, and then after from the DB location, right? So it is what it's suggesting is read only what you need. So what you can do is you can have a query filter. Even it is suggesting you to use the Amazon S3 Select. So Amazon S3 Select is the kind of a new feature provided by the AWS S3. So what it does is, let us suppose you have an S3 file and you want to read it onto the AWS Lambda. It is not that you require the complete file, you just need a single row from that file. So what you will be going to do is, you can use Amazon S3 Select, and Amazon S3 Select help you in reading just one row from that file. Okay. And so like before that, what usually people used to do is, they will download the complete file and then after just open it and read the first line or whatever line required, right? But now you can optimize it. So we will definitely have a different video for this Amazon S3 Select, but as of now I think this is clear. Okay, so third point is smart resource allocation. So this smart resource allocation is very important. What AWS is suggesting, sometimes what happen is, let us suppose you have allocated some memory or RAM to the AWS Lambda. So at 128 MB, it is taking 11 seconds. That cost you 0.00, I mean 0.024628, right? But as you kind of increase the memory size to 1024 MB, it is taking 1.46 second, which is I think nearly 1 by 11th, right? And cost is, if you see the cost, 0.024 0.024628 So this is very little change, and it impact your application is really significant, right? So the time is 1 by 11th and the cost is nearly same. So what AWS is says, always fine tune your Lambda as much as possible. Try to run it on the different memory allocation, and we'll see what's the best optimized memory for it. So although kind of AWS provide a kind of different mechanism to fine tune your Lambda, but we can have a different video for that. But as of now, I think this is very clear. So let's see that from an example as well. So what I will do, I have this code already written. So it is just a code that basically get prime number up to the limit we have provided. Okay, so I will going to copy this code and just paste it here, so that so I have this code already running, so like already ready for you, so that it doesn't waste your time. So maybe you can read this code here, and it is very simple, right? So I will going to run it, test it. Okay, so I will going to test it again. So it is kind of taking 18467 millisecond, right? And the memory we have allocated is 128 MB. So maybe let's see this costing as well at the same time. So what I will do, I will just duplicate its tab as well. So I will search for Lambda here. Okay, so I will just without free tier for now, just to get the exact cost. So let us suppose the request we are kind of, I think 1 lakh, maybe just per hour, and then after the duration of each request is 187 millisecond. We see that, yeah, or maybe 184 now. Memory we have allocated is 128 MB. Yes. Okay, so see, the cost is 41.98 USD, right? So now what I will do is, I will go to the configuration section and then after edit it, and let's just make it 10241 GB, right? Going to save it. I will run it again. So just test it. I will test it again. So if you see now, the duration is 14.62 millisecond, which is really huge. If you like, really less in comparison to the what we got from the last time, that is something around 180, and it is now 14 millisecond only, right? So what I will do, we have already seen the cost for this 128 MB, but now we will see the cost for this 1024 memory. So I will keep all the configuration same, just change the number of request, maybe I can copy from here. So it is per hour I have taken. So that's it. Duration of each request is 14. Then after amount of memory allocated is 1024. Yeah, so that's it. So now you see, even we have increased the RAM, and our Lambda function time got decreased, so we got two benefit. Like obviously the time got less, so that's really great from the application perspective, and the now cost is also reduced, right? So here the cost is 41 USD and here the cost is 31.63 USD. Okay, so that AWS says always try to fine tune your Lambda like on which exact specific memory configuration or like the memory allocation it is working great. Okay, so always fine tune this, but definitely we will discuss is how we can fine tune in the later video. Okay, so that is smart resource allocation. After that we have multi-threading. So what AWS is suggesting is like up to the 1.8 GB memory, it is not providing you any multiple cores, right? Up to that it is only a single core, but after 1.8 GB it has multiple cores. So AWS says try to use multi-threading, but only use multi-threading if your like task is kind of so there are two type of tasks usually, CPU bound task and IO bound task. So if your task is CPU bound, like so there is no point of using multi-threading, but definitely if your task is IO bound you can uh, definitely use multi-threading. So it is kind of a general thing I think we use in daily basis. It doesn't matter your code is running on Lambda or any other service, so we can use that. So after that what it says is kind of always try to minimize the number of libraries dependencies. So what usually people do is like, so sort of let us suppose you have a bigger application and there are multiple dependencies like libraries you required in your code. So you are just going to put all those libraries in a single zip file and use that single zip file on each Lambda. So that is really a wrong practice. What AWS says, try to use only those libraries that you really need in your code, right? So that is the one thing. Second thing is only import what you need. So rather than a generalized import like import boto 3, what you can do is like from boto 3 import s3 client or maybe any client. So that's always try to import specific things. So after that we have an like utilize provision concurrency. So all the above things that we discuss are from the code perspective or maybe memory or RAM like that, but this is from the infrastructure. So what AWS is suggest is rather than what you can do is like let us suppose your request is come. So what AWS will going to do is it will create your container at that time only. So what AWS suggests you to have an provision concurrency, like you can have a Lambda function that is already pre-ran. Okay, so container is already up by the AWS itself, and whenever it got request, it will going to execute those requests from the same container. So kind of it is like pre-preparing the container for you. Like just we go in the hotel and the hotel kind of have all the like the basic requirements of preparing a dish ready. So it is just similar to that. So what we can do is we can go on the console and then after define provision concurrency. So we can define it like how many instances we wanted to have pre-run, right? So we can define that, but maybe we can discuss this in a later video so that it doesn't get very large. So I think yeah, that's it. So we will discuss this in the later video. Okay, thank you.